to take something like 127 and divide it by 3. Okay. Do you
Okay.
remember which number goes outside the box and which number goes inside the box?
The big number.
Which the big number goes where? Inside or outside?
Inside.
Yes, and you actually want to say it this way: the first number. The first number goes inside, and the second number goes outside. And the reason is not the first number is not always the bigger number. Okay. Now, does 3 go into 1?
3, no.
Does 3 go into 12?
Yes.
Okay, how many times?
1.
So here's what I'm sorry, go ahead. This is what I'm asking you. 3 times what number gets you to 12? 4. Now, does the 4 go above the 1 or above the 2?
Above the 2.
It goes above the 2. That's correct. Excellent. Okay. 4 times 3 is 12. You subtract. What is 12 minus 12?
0.
0. And so you bring the 7 down. Does 3 go into 7?
Yes.
How many times?
2.
2 times. Yes. Now it does not go in perfectly. So 2 times 3 is 6.
And then there's a remainder 1.
There's a remainder of 1. That is correct. Good. Okay. Let's try something more difficult here. I didn't know what your understanding would be of this. Why this is still showing. It's interesting. Let me. Okay. We'll deal with that another time. So let's go 542 divided by 9. So again, which number goes outside the house? Which number goes inside the house?
So 542 goes inside the box and 9 goes outside.
Okay, now maybe I misspoke, but this is 5,042. I probably misspoke, but this is 5,042. All right, does 9 go into 5?
No.
Does 9 go into 50?
Let me see. Yes.
Okay, how many times?
5.
5 times. 5 times 9 is 45. You subtract, what is 50 minus 45?
50 minus 45 is 15.
Say that again. 15, 15?
Yes.
Try again. Let's take a look at that here. So if you recall, you cannot subtract 5 from 0. So you have to borrow from the 5. What happens when you borrow from the 5? Remember how that 5 goes down to a 4?
Yes.
Okay, so what is 10 minus 5?
5.
5. And then how about 4 minus 4?
0.
0. So do you write the 0?
Yes, and you can, and if you don't want, you don't have to. I think.
Well, it's kind of awkward, you know. You can, like you said, it's a number that is the result, but the question is should we write it? And the answer is eventually you will not write it. Okay. So 50 minus 45 is 5. Bring down the 4. How many times does 9 go into 54?
6.
6 times. And 6 times 9 is 54. Subtract, and you bring the 2 down like that. So what is the 2 in our problem?
The 2.
You said it. What?
The 2 is the remainder.
It is the remainder. Good. Very good. Okay. So you said you had some pencil and paper. I'm going to give you a problem to try here. Is that okay?
Yeah.
All right. So here we go. 396 divided by 7. So go ahead and work that out on your own and let me know your final answer.
Okay, I got it.
Oh, that was fast. What is your final answer?
56 remainder 4.
56 remainder 4. Very good. Okay. All right. Now let's talk about a different topic here. Because it sounds like you actually know how to do this just fine here. Have you talked at all about dividing decimals, like something like 0.2 divided by 0.05?
I I did it with I divided by with dollars, but I don't think I remember doing this.
Okay, how about multiplication? Like, let's just say I ask you to do something else, like 1.25 times 0.5. Is that something that you've seen this year?
No. I only learned how to add fractions.
Okay, let's take a look at that. All right, so let's talk about how to add fractions. Let's say I ask you to add 7/10 plus 2/10. What does that become?
9/10.
9/10. Very good. How about 1/2 plus 1/2?
It becomes 2/2, but you can make it equal 1.
That's right.
That's
Why is that? Why is that 1?
because the denominator and the top number are the same. Anything that's the same with the denominator equals 1.
That's very good. Very good. The other way to think about division or fraction here is it's a sharing problem. Okay. Imagine you have two things to share and you have two people to share with. So if you have two things to share and two people to share with, how many things does each person get?
1.
1. Yeah. All right. So that's great. Now, what about we'll do something a little bit harder. Let's say it's 3/4 plus 3/4. This becomes 6/4, but do you remember what to do from
Divide it.
here? Okay, so help me out here. When you say divide it, do you mean divide the top, divide the bottom, divide the top by the bottom? Like, are you saying this? What do you mean by that?
I'm like, I, I don't know how to explain it though.
That's okay. Why don't you work something out here? I guess I'm curious what you've learned in class. You're doing great. Um, Go ahead and just work this out. Let me know what you come up with.
Okay. I think I got something.
Say that again.
I think I got something.
Okay, what
But
do you have?
I don't remember this, but I think it could be a mixed number. It could be 1 and 2/4.
Okay, that is true. That is correct. It is 1 and 2/4. Now, how about this part on the right, though? This 2/4. Is there any way to reduce that?
You can make it 1/2.
You can make it 1 and 1/2. Good. Okay, so let's talk a little bit. Let's look at a new problem here. Let's say it's 7/10 plus 9/10. I want
Okay.
you to add the fractions, write it as a mixed number, and then reduce if you can.
Okay, I think I got something.
Okay, what do you have?
I got a mixed number. I got 1 whole and 8/10.
Okay, where did the 8/10 come from? What is 7 plus 9?
7 plus 9 equals 18.
Try again. Try again. 7 plus 9 is 16.
Oh, yeah. 6/10. 1 and 6/10. One whole
Okay,
and
now, does this fraction reduce? Is there a
mm,
number that goes into 6 and 10? Like, can you divide them both by 2?
oh yeah. Okay, let me see. Wait, I need to do this. Okay, 6 divided by 2 could equal, so that equals 4 equals 3/5.
It is 3/5. Good. Okay. So we're gonna talk a little bit about how to reduce fractions right now, because there's just a tiny gap there that I'm seeing. And before we can reduce fractions, do you remember, have you ever heard of what's called a prime number?
Yes.
What is the smallest prime number, if you know?
1
1 is not a prime number.
is not.
It's a composite number. Yeah. The smallest prime number is 2.
Oh, I thought it was 3.
Next is 3, then 5, then 7, then 11, and so on. These go on forever. Now, 2 is the only even prime number. Okay. Now, when you reduce a fraction, like let's say you want to reduce something like 2 divided by 6, you always start with 2. And you ask yourself, can I divide the top and the bottom by 2? So can you tell me what 2 divided by 2 is?
1
1 over,
1 over 1/3. 1/3.
um, the next thing, let's look at another one here. Let's look at 4/12. Okay. Can you divide 4 by 2?
Yes. And it would be 2.
On the top, what about on the bottom?
On the bottom, it would be 6.
Okay. Now here's the thing. If something works, you try it again. So divide this by 2. So you keep trying it until it doesn't work anymore.
1/3.
Very good. All right, so let's try another one here. Let's say it's oh, I don't know. Let's go 14 divided by 20. Okay. Can you divide the top and bottom by 2?
Yes.
All right, what does that become?
It becomes, okay, so the top number will be 7 and the denominator will be 10.
Very good. Okay. So here is one for you to try on your own. I want you to reduce this fraction, please.
Okay. Finished.
Okay, what is your answer?
I got 4/10.
Okay, but can you keep going? Can you reduce that?
Yes.
Okay, so keep going. This is not your final answer. This is an intermediate answer.
2/5.
2/5, good. All right, let me give you another one to try. All right, take a look at that. Go ahead and work that out, please. How are you doing on this one?
I just finished.
Okay, what is your answer?
I got 3/7.
3/7 is correct. Very good. All right. Let's do one more, and then I'll maybe transition to something else here.
Okay.
All right, we
5.
are close. We got 5/8.
Yes.
Excellent. All right, good job, Nicholas. Well, you and I are gonna be done right there. Now, if you could ask Aiden to jump on, and
Okay.
we'll maybe talk at the end. Thank you so much.
Hi, Matthew.
Hello.
Aiden. Okay, so like I said before, it's hard to get him. You want to talk to Matthew? You can just chit chat with him. We're just doing a trial. Can you come over here, please?